Hi everyone. So today I'm going to teach you how we can create a repository in our local system and push it into cloud. So we will create a Git repository and a cloud repository. So we will be linking cloud repository with the Git repository and see the process on how we push project files or folders from Git repository to the cloud repository. So before starting the session, I would like you to download Git from this link. You can download Git Bash for Windows. Download the latest version, and if you are having a Mac, then you can download Git for Mac OS. So, and also I would like you to say this, that I would like to say that you create a GitHub account. It's easy. Go to github.com and sign up over there. Once you sign up over there, then we will be ready to start. So let me tell you first. So what is Git? So Git is a version control system. So it is like a mini file tracking system, which is used to maintain history. With this file tracking system, every operation and changes performed on the file or folder can be tracked. Let's consider there is a team which is doing a project, and if a team is consisting of 5 members, and a person is doing the changes for a file or folder, then it can be tracked in Git so that the other persons will also know that what kind of changes have been done in the Git when they go and check in the GitHub history. So with this, I would say changes are kept in the form of a commit history. Okay. So if you want to go back to any particular history after making the changes to a file or folder, it can be tracked in the commit history. So I would like to show you about this commit history. Once I will go and start with the command line interface. So here in GitHub and Git, we call repository, which is a folder. Okay, so the folder is called as repository, where all projects reside. So let me start with this. So let me explain about version control system. So we have two types of version control system. One is a centralized version control system, and another one is a distributed version control system. So the Git is a distributed version control system. So I will say what is centralized version control system first. So in a centralized version control system, all the local system is connected to the server. Okay, all the local system is connected to a server, and if the server goes down, let's consider this is the server and these are the local systems. Okay, so if the server goes down, all the projects or files or folders would be lost and not be able possible to retrieve unless there is a copy of it in the local system. Okay, so this is, let's consider this is the main server. If this main server goes down, how are the local system is going to access the file, right? I mean, if this goes down, this file cannot be accessed after that. The whatever file that has been uploaded in the local system, it's gone. I mean, it's of no use, you know. So that's why there is a disadvantage with using centralized version control system, because we don't have a cloud over here where the file or folder can be accessed by each individual. Let's consider a person, developer one is working on some project, and he commits some changes and upload, and then developer two is doing some changes to the project that has been done by developer one, and developer three is doing the commit and changes to the project that has been done by developer two. Okay, but what happens is that history is not maintained over here. So you upload here, and it's the latest whatever file you have uploaded, that will be present. I mean, if you want to go back to the previous file which was developed, which the changes which you don't want, it's not able to access that file. You won't be able to access that file. So this is the disadvantage with the centralized version control system, because history is not maintained over here. Okay, so let's come to the distributed control version control system. We here we may or may not have a server. It's a cloud, okay? So here every local system, see, every local system will be connected to each other. Here we keep track of all the changes done in single project on every local system. In each and every local system, we will have the project changes that have been made. And here there is one level extra. You see, there is in central repository, there is only one repository, but we have three repositories over here. So whatever changes that has been made from developer one, and it is going to be uploaded into the cloud. And if a developer to do the changes into the file, the whatever the previous file the developer one was uploaded, it will be restored in the history, and the changes can be tracked by developer 3. And the main advantage of this system is that here we keep track of all changes done on single project on every local system. The whole project level details will be saved in every local system over here. So if we have a server, we will be maintaining a copy here. Okay, that is project copy is maintained in every local system as well as on the server. Okay, got it? Okay, so next come to Git. Okay, so Git is only used for building projects. Reminder, let me remind you guys. So Git is only used for building projects and not for loading heavy files. So you can use this GitHub for only for building projects and projects which are in KBs or MB, but not heavy files such as videos and other audios files and all. So it is like a Facebook for developers. And Git, let me come to Git. So when you download the Git Bash for Windows, so you will be able to access here, search Git Bash, you will be able to open this Git cache. So this is known as Git. Okay, this is known as Git. This is a command line interface. So Git, it is a repository maintained at local system level. We'll be working on a local system. Okay, so GitHub, this screen is a GitHub. It's a cloud repository and it implements Git. Okay, in Git we have three different stages. Let me show you the different stages in Git. So yeah, in Git, we have three different stages. They are working directory, staging area, and local repository. So let me tell you about the local repository. So whenever you initialize the folder, uh, as a Git repository, then the .git folder gets created in that particular folder. All the commit history and metadata related changes will be saved into this. So first in the working directory, you will first have all the files and folders that have been created by you. Let's consider some .py file has been created from you. So then first we have to initialize using git initialize .git. First, when we do the initialization, then a working directory, in the working directory, we will have a hidden file which will be saved in the name of .git. And this is not a normal folder. This is a Git folder and only used for Git, acts as a Git repository. Okay, so now whatever files and folders and changes you do on a file, that will be stored in form of Git. Okay, so once you have done the initialization and creating of a file, then you can add this untracked status file into the staging area by the help of git add command. Okay, so here the untracked status, untracked files will be present in the working directory. Once you have given the git add command for that files, then the files will move to the staging area. Then here, whatever files you wanted to load to the Git repository will be present in the staging area. Then you have to commit the changes that has to be done on the local repository. Okay, so we have cloud repository that is hosted on GitHub. This is the cloud repository that is hosted on GitHub. In our case, it's working as a server. Okay, this is a server, and in this case, we create a folder over here. Whenever you are going to push a code from a local system, whenever you are going to push a cloud from local system to cloud repository, the cloud repository should support. Okay, in the working directory, the Git status shows the projects that are untracked by Git system. Okay, the project file should be moved to staging area using the staging area. From the staging area to local repository, this is the local repository. We have to move using git commit command. So we have to move using git commit command. Okay, it is creating the commit history in the local repository, like who performed the changes, commit id, time, email id of the person who committed the changes onto project file. This creates the commit history. So in the cloud repository, you can fetch or pull the changes. Okay, in the cloud repository. This is the cloud repository. You can pull or fetch the change, fetch or pull the changes. The cloud repository has to be linked with the working directory. I will show you in a minute how it can be done. And we will link the cloud repository with the working directory. Okay, this is our cloud repository. Okay, and this is our working directory. We have to link the cloud repository with the working directory using the git remote add origin command. Okay, so this is the git add origin command using which we will be connecting GitHub and the Git bash. Okay, so I would like to say uh, the staging area here. Where is it? Okay, the staging area here is a buffer between working directory and the local repository. Okay, and when you want to go back to the particular history and see what changes are done, you can revert back. Okay, and staging area helps the liberty for you to make any changes. So let me tell you the this commit thing. So commit means you are saving the changes. Every commit history will be recorded. We can go back to the particular history and see what changes have had others performed on the files or folders. And let me start with using of GitHub, Git bash. So this is our command line interface. So let me start by clicking on, let's see the current path, present working directory. It's PWD, which should be the present working directory. And so now we are in a users. Currently we are at user level. So now we will list all the files and folders in the current working directory. The command is ls. So these are the files and folders that are there in our current working directory. So now we move to the current directory. CD is current directory. We move to the directory called desktop. Here we have the desktop repository. So we will go to desktop. Okay. So presently we are currently our current working directory is desktop. So now we see the list of files and folders that are present. But before that, let me create a folder, that is, let me create a repository inside a desktop known as my project. Okay, so here is the problem. There's it's saying that we cannot create directly my project because its file is already exists. In my case, it seems like there is already a file in the name of my project. Let me check. Okay, so here you can see there is a my project folder already present. So let me remove that directory. So we can remove that using a remove directory rmdir command. And then the we give folder name. Okay. Now we will create uh, we will create a new directory in the name of my project. So now we have created a folder or repository named as my project. Let's go to my project folder. So this CD, which is used to move from one directory to another directory. So now we are moving to the my project folder. So let me check if there is any files or folders that is present inside this. There is no files or folders present inside it. Let me check the present working directory, which is obviously my project. So you can see my project working directory is in desktop under desktop folder, and we have my project folder. Okay. Now we are currently at my project. Now, what you do is you initialize empty Git repository in current directory. This can be done using Git init command. Okay, so initialized empty Git repository in C. Okay, so this is not a normal folder. This is a Git folder. As I said in before, we have to initialize Git using a Git init command for that to act as a Git repository. Okay. So now what we do is that we will see the present working directory. Like it's my project. And now we will list all the files and folders that are present in my project. So you don't see any files and folders, but Git init actually creates a hidden file under my project. So that can be viewed using command ls-al, which will be showing us all the hidden files that are present in the current directory, that is hidden files also, and all the other files. Okay, so you can see here there is a .git command folder. This is the folder that makes a folder a Git repository. Now my project works like a Git repository. Now it's not a normal folder. Okay. And now what we do is, once we have done the Git initialization, we create a file F1 using touch command with a .py extension. So let's create a file F1 touch. We can create it by touch command. We will create file with the .py extension, which is a Python file. So we have created the touch fun.py file. Now we will list all the files and folders in the current directory using ls command. So you can see that there is f1.py file has been created. To view the contents of file f1, we will use the command cat f1.py. So you can see that there is no content that is currently present in the f1.py. Okay, so what we do is we create a file f2 using the echo command. Echo, and we shall give a py extension for that. Using echo command, you can create a file and write something onto it. So I would like to show you something. Let's write something in said that hello guys and f2.py. So let me see what are the contents that is present in the current folder. So you can see that we have f2.py that is present in the folder. And let's see the contents that is present, cat f2.py. Okay, so you can see this is the content that is present inside this. And now what we do is, now let's change something. We create a file f3 using vim command with .html extension. So using vim command, you can create a file and write something to it. Okay. After, let me write that vim command now. Vim f3.html. Okay. So now we are in the textual area of the f3.html file. So you can actually add contents inside this. So let me write a pseudocode or something like that. Print uh, hello guys. Okay. Hello guys is already present. Okay. And let me click on escape and WQ. Okay, f3.html. Let me see what is present in this f3.html. So you can see hello guy I is present. Let me go to that vim f3.html again. HTML file again. So I'm not able to write something. I don't know why. Let me check. Escape. WQ. Okay, let it be like that. So let me create another folder. Vim f4.py f4.py file. Print. I don't know why it's like this. Okay, let me go back. Yeah, for going back, I forgot to say, let me tell you something. So when you write a vim command, a vim dot f5, or let me write f5 dot text, txt, what you have to do is that when you write this command, click on enter and write something here. Hello, whatever you want, you can write here. And after writing here, what you can do is that, let me write print small print hello world. Okay. So once you write anything over here, press escape first, and after pressing escape, click on colon WQ. I repeat, once you press on escape, after that, at the bottom, you don't have to do anything. First, you press escape, then you click on colon and write WQ. That's it. Let me tell you some once again. Click on escape, then colon WQ and press enter. Okay. So you will go back to the file, go back to the command line interface. Okay, let me tell you once again. Let me write vim f6.html or .py, then click enter. Now write something here, and after that click on escape, and after that click on colon and WQ. Small, not capital WQ, it's colon small WQ, and click on enter. Okay. Okay. So now the what you have to do is that, so now we have all the files that have been created. Let me see how many files that have been created inside the my project folder. So we have F1, F2, F3, F4, F5, F6. So we have created 6 files, and there is some contents inside that file. So first, what we will do, we will first check Git status. Okay. Now we can see that we can see that uh, this shows that currently we are in master branch, and F1, F2, F3, F4, and F5 and F6 are in the untracked files, and that is currently they are inside the working directory. Okay, so let me show you that. So now currently all the files are present over here in the working directory. So let me go to the command line interface, git bash. Now what to do is that now currently F6 is in untracked status. Okay, you can see here F6 is in untracked status. First, what we do, we move F6 from untracked status into staging area. So let's do that. This can be done using a command git add. So now the F6 file is in the working directory. We will move the file from the working directory to the staging area using the command git add. So git add f6.py file. Now the file will have its original links in here. Okay. Ignore the warnings. Now go to the right git status. Now we can see that F6 has moved to the staging area. This is the staging area, which is the changes to be committed, and this is the working directory. Okay. Now what you do? Now move F3 and F4 and F5 into the staging area. So let's move the other F3, F4, F5 files in the staging area, or let's move only F4 and F5. Okay, so git add F4 dot py space F5 dot txt. Okay, now we can see in the git status that the other files F4 and F5 are also moved to the staging area. So presently we are now in F3, F4, F5 in the staging area, and the other files are in the working directory. So let's do one thing. Let's uh, send all the files from the working directly to the staging area. So this can be done using git add, and after writing git add, you just have to write space dot git add space dot. This will move all the files with the extension into the staging area. Okay, let's check the git status again. Okay, so now we can see that we don't have any file that is present in the working directory. All the files have been moved to the staging area. Now we need to perform commit, but before performing commit, we need to do the setup. So we do a commit so that git commit is performed so that the files in the staging area can be moved to the local repositories where changes saved to the local repository as commits. Okay. So basically, when you do the git commit, it should be maintained who have done the commit. So we need to do the setup. So when you push the code to cloud repository, when you make commit on the local system, the commit details will have username and email ID so that other project members can see who has done the commit. So let's do one thing. Let's set up the basic requirements where we give the user configuration like username and also user email ID so that if a person is performing some changes, then it is possible to keep track on what kind of changes that has been made and who has performed the changes on the project in the project level. So the command for giving username is git config global user dot name and write or Ranger. Let me create the name of the user is Ranger, and let me give the email ID of the user.email, and it's Ranger. So we have now given the username and the email ID of the user. So whatever commit that is being done by a user will be stored and the Git repository, Git cloud repository, and it shows who has committed the changes and at what time, and also the ID of the person. So we have done the configuration at the global level. Global is used. So here we use global so that the settings happens in the global and not at the local repository only. Okay. Now let me write git config global or to git config global core dot out to crlf 2. Okay, so here we have given we have crlf, which auto crlf, which represents endings. And when you're pushing the code into GitHub from Windows, the line endings are represented by crlf. Okay, so basically the below command makes the file compatible for different types of operating system. So click on enter. Okay, so now after performing these changes, now what we can do is, now since the settings are done, we perform git commit now. Okay, move the file to the local repository with a message, and this can be done by using git commit bracket open. This is our first commit for this class. Okay, so we have done our okay. Well, there is some error it seems. Git card, this is the first card for this class. Okay, we have not included the message. We have to write M over here because this is the message we are passing. Let me check now. Yeah, yeah. So we have done. So all the files have been committed and all the files have moved to the staging. All the files have been moved to the uh, cloud repository, local repository. See, this is the git commit command, and all the files which were in the staging area have been moved to git repository. And you can see here git commit command, and we have moved all the files from the staging area into local repository. So to now you can check the status of the this thing. Uh, Git status you can check. Now we could see that there is no file that is present in the staging area since all the files have been moved to the local repository. Okay. Now, to push it into cloud repository, we need to check whether the local repository is linked to any cloud account or not. If it's not showing anything, it's not linked to any cloud repository. So let's check now if our Git local repository is linked with the cloud repository using the command git remote p. So you can't see anything right over here. So our cloud repository is not linked with the local repository currently. So what we do is go to your cloud repository. So whatever GitHub account you created, go there, So this is the GitHub account you have created. So what you do, you click on create repository. So go to GitHub, go to here, go to click on this, and once you are here, then click on create repository and give repository name as project project. Then in the description, you can write test project, test underscore project. Okay, so we have, and this is a when you click on create new repository, a new repository will be created, and you have to give the repository name and give the description and let it be public, this thing, and go and click on click repository. Once the repository is created, then you have to copy this link. Okay, copy this link or click over here and copy the link and go here and write the command. Go to your, okay, write the command git remote add origin and paste the command. So you have to right click and paste the command over here. Okay, so you have pasted the command over here. So git remote add origin, this link whichever you have the used for creating the repository. So what happened here is when you go into your cloud repository, you copied the link for the git https. You have copied the git https link, hypertextual link, and you have given the path into the local repository where you want all the files and folders from the local repository to be moved. So now whatever files and folders are there in the local repository will move into this project, that is into the repository that you created previously in the GitHub account. Okay. Now press enter. Okay. Now the job is done. Now what you have to do is that now we have linked the local repository with the cloud repository. Okay. You have to go and check it by I also have to tell you something. Uh, there might be a case that when you add origin, there might be a case you encounter the login to the GitHub account pop-up screen. Don't worry, you just have to log in to the GitHub screen. Then it won't be a problem for you. You can use that GitHub repository. So let's come back. Okay. Okay. So now we are in the we have completed this remote access. So now let's check if our GitHub account is if our local repository is actually now if it is connected with the cloud, GitHub cloud. So this can be checked by the command git remote. So yeah, you can see here. Yeah, you can see that here we have origin, link, and fetch command, fetch, and origin, link, and the push. Okay, so now we can push the cloud to the code to the cloud repository. That is done. Now we are pushing the master to the cloud repository. Okay, we are now pushing the master to cloud repository. This can be done by git push git push uh, git push view search. Before that, I wanted to tell you something. So now you see the link, right? Now we have linked other local repositories. So this shows that this too shows that we have linked the local repository with the cloud repository. Now we can push the code to the cloud repository. Okay. So whatever code is present, we can push into cloud repository. So we can perform the changes to the cloud repository. You need to enter the GitHub credentials when you click on this. Okay, you need to enter the GitHub credential. Let me write the command minus f git push minus f origin master. Okay, so we are pushing the master to the cloud repository. Okay, we are pushing the master to the cloud repository master branch. Okay, now once this is done, go to the GitHub account and refresh. Okay, so under the project file, that repository which you created previously, under that, all the files have been uploaded. Okay, all the files whichever you have is uploaded inside the project repository. So you can go and check the contents inside those things. So under f1.py you don't have any contents present. In f2.py you can check. We have some text written over here, and also you can go and check a whole history. This can be done. Go to file. Let me check. Okay. Okay. Let's go to project back, and under f3.html, let me see what kind of text. Okay, what I wanted to say about history thing. Okay, when you click on this history, we'll get at what time the changes have been made and who has done the changes. So the user which whose name is Ranger has committed change 8 minutes ago. Okay, so now go back to the project file. And also, I wanted to tell you one thing. After you have uploaded all the files in the GitHub account, you can even download this by clicking on cloud. So you can go and copy the link, or you can directly download as the zip folder, or you can even open with GitHub desktop. Okay. Okay. So let's go to the git bash and see git log. This will tell us the user who actually made the changes and his email ID and at what time he did the changes. So at 22:46 hour he has done the changes. So the message which he has given is this is our first commit for this class. So the message we had which we had given previously here. So it is showing this thing. So once you have created or once you have pushed the files from the Git bash into the GitHub account, you can even delete this file. You can view the contents that are present in the file by clicking on it. And let me see what else is there inside this file. Let's click on insights. Okay, nothing is there. Let's go to projects, and under projects, let's click on master. Okay, now we are currently at master. One commit has been done. Okay. Let's go to file and go to file. Okay, go back. Okay, now let's go to history. Okay, there is nothing inside history. Okay. So I wanted to show you this, guys. So in the f1.py file that we created, we have an empty file, nothing, no context is there inside that. In the f2.py file, we have this content. And similarly, in other file, we have different contents inside those F3, F4, F5, and F6. This can be all viewed at the same time. So if you are assuming how you can delete all these files once you have, if you don't want to use this file anymore, or if you don't want the repository anymore, you can delete this repository by clicking on settings and go scroll down and click on delete this repository. Let me tell you once again, go to settings, go to the bottom of the screen, and here there is a delete this repository option will be there. You can click on that and click on this I want to delete. I have read and understand this effect. Then you can write this dash under access and project. So this repository will be deleted now and confirm access. Okay, now you don't have any repository. You can see you don't have any repository now. So this is all about Git and GitHub. Hope you liked the session.